So the test is Raabe's test. The first we will give you the statement for that. Statement is if un is a positive term series and limit n tends to infinity n, un plus 1 divided by un minus 1 is equal to n, then that is L basically value, then the series is convergent. That is a given series un is convergent if L is greater than 1, and the series is divergent if L is less than 1, and test fails at L is equal to 1. And one more thing that is important in Raabe's test is that it is applied when ratio test fails. Ratio test fails, then we'll apply the Raabe's test. Okay, so the example is the example is first is 2 by 3 plus 2 into 4 divided by 3 into 5 plus 2 into 4 into 6 divided by 3 into 5 into 7 plus 2 into 4 into 6 into 8 divided by 3 into 5 into 7 into 9, and so on. So now to apply the test, first we need to find out the un term. So here if you see, un term will be 2.4.6.8 2n divided by 1.3.5 2n plus 1. Okay, so you can check it also that it is correct or not. For n is equal to 1, u1 is, that is 2 into 1, so it is a multiplication. This will be your first term. This will be the term that that term we have to stop our multiplication. Okay, and it is in the even multiplication, to will skip one term and then stop at this term. Okay, similarly we'll do in the denominator. So like if we have for n is equal to 1, the first term is 2, and 2 into 1 is 2, so that is we only have one term in the numerator, that is 2, and in the denominator we have 2 into 1 plus 1, that is 3. So see, we have written 1 here because 1 is multiplication, doesn't affect if we write 1 or not. So if we are writing it also, then it is 1 by 2 3, and we can write it like that 2 by 3 also, right? So it will be the first term like we have in the given question. Now for n is equal to 2, u2 is equal to 2 into the last term is we have 2 into 2, that is 4. So that is it will vary till 4, skipping the odd term. So it will be 2 into 4. Now in the denominator we have 2, so 2 into 2 plus 1, that is 5. So it will go 1 to 2, skipping the even terms. So it is this. So we can write it like that, 2 into 4, 3 into 5. Similarly you can find any term that is the nth term I assume is correct. That's how you check it. Now if we have first the ratio, Raabe's test is applied when ratio test fails, and for ratio test we need to find un plus 1, and un plus 1 is equal to, if you plus n plus 1 here, then it will be 2 into 4 into 6 dot 2n plus 2. If you put n plus 1 in the place of n, divided by 1.3.5 to n plus 1, and if you put n plus 1 instead of n, then it will be 2n plus 3. Now we didn't write the even term here, that is 2n plus 2, Why? Because in the quotient, in the denominator we are only taking the odd terms. Okay, that's why we are not taking this term. Okay, now as if we apply the ratio test according to now ratio test first we'll find out. So for ratio test we need to find un divided by un plus 1. So it will be equal to 2 into 4 into 6 into 8 dot 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 2n divided by 1 dot 3 dot 5 2n plus 1 multiplied by 1 dot 3 dot 5 2n plus 1 2n plus 3 divided by 2 into 4 into 6 2n plus 2. So now we cut the common terms. Okay, so we are left with only 2n plus 3 divided by 2n plus 2. Now to apply the ratio test, now we have to find the limit of this term. So limit n tends to infinity un divided by un plus 1 is equal to limit n tends to infinity 2n plus 3 divided by 2n plus 2, right? So it will be equal to, if you take n common here, it will be 2 plus 3 by n divided by 2 plus 2 by n. So it will be equal to 1. Basically n 3 by n and 2 by n tends to 0. As n tends to infinity, you are left with 2 divided by 2 and the answer is 1. And according to by ratio test, if this is our L, if the test fails, according to ratio test, okay, the test fails at L is equal to 1. Okay, so now we'll apply the Raabe's test. So Raabe's test. Okay, so we have limit n tends to infinity n un plus 1 minus 1. So it will be equal to limit n tends to infinity n 2n plus 3 divided by 2n plus 2 minus 1. Okay, so it will be equal to limit n tends to infinity n divided by 2n plus 1. If you simplify it, it will come out this, and it will be equal to, if you take this, will be equal to limit n tends to infinity, if you take n common from numerator and denominator, it will be 1 by 2 plus 1 by n, and this will be equal to 1 by 2, and 1 by 2 is less than 1. So therefore the given series is convergent, hence by the Raabe's test, the given series is sorry, not convergent, it is divergent, because we have L less than equal to 1. That's it. This is the test for Raabe's test. In some books, that's the important information that I want to give here, that in some books ratio test is used in the form un plus 1 divided by un. So you can, if you use that form also, then you will get the same answer. Okay, So thank you for watching the video.